screen visible?
Yeah, it's visible.
Okay, so this is my account. Okay, and I have done so many projects, around 26, and for these. Okay, and this is 10K CAD, as you know. Okay, so this is online simulator where you can design your own circuit, and you can work with your projects. But here are some limitations, like less amount of sensors are here. Okay, so this is our working bench. Okay, and here are the some list of the components, and here are some like list of the like circuit assemble and microbit and Arduino basic and all. Okay, so we will go to basic, and here are some so many things, as you can see. Okay, so here is the Arduino Uno board, as you guys know, and let me tell you about it. Okay, so this is your USB board, where you can connect your computer. Okay, with this USB cable, and here is 12 volt 1 ampere power supply. You can connect it, and this is the power regulator IC, and here is some circuits, and this is a like 16 megahertz clock signal. So for running any like integrated circuit, you have to give some clock signal to work it. Okay, so here is 16 megahertz clock signal work. Okay, and here is reset button. Okay, when you press this, then your board will be reset, and your program will restart. Okay, from the base, from the starting. Okay, and this is the your IC, and here are some pins, and here is some pin. Okay, so this pin column is for like power. Okay, so like for power, this is a V in. V in. So V in basically is for what? Like when you connect 12 volt 5 ampere 1 ampere here, then you will receive 12 volt 1 ampere here, and you can connect with the ground, and you can take the power out. If you want to connect with the external power like 12 volt 1 ampere, you want to connect it with using two wires, you can connect here also. Okay, and these are the ground pins, and here is one ground also. So you have three ground pins here. Okay, and here is 5 volt, and here is 3.3 volt, and here is reset switch. So this reset switch, you want to extend it to the ground and take this type of switch, or this type of switch, you can connect it. Okay, and other wires, you don't need to think about it. Okay, so these are the main pins. Okay, here is the analog pins. Analog pins are different from the digital pin. Digital pin is 0 and 1. Here is the analog pin. Analog pin basically like connect from 1 to 1025, I guess 24. Okay,
24,
uh,
24.
yeah, 24. Okay,
0
so
to 1000 to 0
yeah,
not 24
1024.
102 हाँ इन्होंने 23
Yeah,
0 to 1023.
okay. So you can connect the analog pins here, and you can read and write from here. Okay, and here is the digital pins, and the major thing, the SDL and SCL pin, which you have to which Utkarsh told in first session, the pin number A4 and pin number A5. Okay, so for the
So used in I2C communications.
I2C communication. Okay, and here is the HCL and SGA pin, especially for I2C communication also. Okay, and this is the ground pin, and these like 14 pins are here for the digital communication for 0 and 1. And in front of where is these type of symbol, like approximation symbol, which pin are PWM pin, pulse wide modulation, which is like work with between 0 to 250 225. Okay, and these are the RX and TX pin. You want to like receive and transmit using a fingerprint sensor, or some radio communication, you can connect with these pins. Okay, and these are the digital pins, other pins including. Okay, so if you want to like switch an LED, you program it, and connect a digital pin with the LED, and connect it with the ground, or 5 volt. Okay, and then you program it, and you can run it. Okay, you have some sensors, like you want to use servo motor. Okay, so for servo motor, you give a signal PWM, and you connect some digital pin with it, and 5 volt and ground, and then you write code, and then you will run the servo motor with it. Okay, so the mainly major thing is like you want to use some sensors which work in digital form, then you can connect it like a relay, as you know, like a relay work in digital form. Okay, and for analog signals like temperature sensor, humidity sensor, and gas sensors, you can connect here also. Okay, so this is
Okay.
the basic of this Arduino board, and is that clear?
Okay. So should I start the class?
Yes, we are.
Okay,
Okay. So
continue. Let
guys,
me
are
mute
you?
myself.
Oh, sure. So guys, are you ready for this exciting new session for the sensors and all? Okay.
Yes.
Okay. Very good. Kind of good responses I'm seeing. So, firstly, told me like in the last session, uh, how many of you had practiced it on the simulator and all? There's no reaction. Any anyone practice these things or not at your own? Good, good. Pankaj is saying I try to. Good, very good. So I'm gonna go elsewhere. Okay, I will definitely practice tomorrow. Okay, no problem. So I will start the session and I'm just presenting my screen over there. Okay, 1 minute. Okay, I think screen is visible to all of you guys, right?
Yes, yes.
Okay, okay. So we will start our today's workshop on the sensors and all. Okay, let's switch it. Okay, so it's our introductory session on the sensors. Basically, what is the sensor? The first question arises with what is the sensor, right? Sensor. Do you know that microcontrollers actually work in the various aspects? Like you give some input data to the microcontrollers. On the basis of that particular data, microcontrollers perform some task and do something. But sometimes we might have seen that microcontroller needs sensing from the outer environment, right? Like let me tell you in some detailed way. Okay, as you've seen in the train and in the public places, there is a fire alarm sensor, like available, right? Fire alarm sensor. When the fire actually occurs, so this sensors start giving signal to all of you, right? So how the microcontrollers question is arises how microcontroller how get these things like now the fire is coming and not coming not means fire is there or not. So for the sensing from the outer environment means this is our outer environment means where we are situating the outer environment and it is basically sensing from the outer environment. So with the help of sensors. So here we need a sensor uh, for which we can sense from the outer environment, right? So in the market, there's a kind of sensors are there. Even though we will see the practical spectrum of the sensors and all. Okay. So like a sensor is a device which detect and respond to the some type of input from a physical environment, right? As I told you, the input can be light. Yeah, it can be light like. you sign automatic street light system, like when sun sets. So what happens with the sun sets, like it's kind of light will turn off, like, and yeah, when sun sets, like a light will be turned on, right? So basically what happens, there's a sensor which sends the sun's light. Okay, on the basis of this on the basis of the light intensity, it will decide whether the other street light will be on and off, like heat sensors, like some of you seen in your computers when you play the games and all. So your computer starts like a burning and all, not a burning, so you start heating and all. So how the processor knows that heat is start, that what's the temperature is? Yes. So for this particular task, the sensors comes in the picture, like motion sensors for the detecting the motion, moisture, like in the air conditioner. There's a kind of sensor are there, like temperature sensor, also moisture sensor, which basically detect the humidity of outer environment, like how humid it is, and they will decide so how what amount of cooling is needed or not, right? Like pressure sensors and other kind of sensors are there. Right? Actually, the sensors convert this input to a electrical signal that can be read by a microcontroller. Like I don't know what is the meant for this particular line. See, if you use a microcontroller, so microcontroller only like understand the electrical signals, right, in the form of zeros and one. If you are dealing with the digital, so either it is zero, either it is one, like it's a high or low, it know only those two signals. If you are dealing with the analog, so 0 to 1024, right, between the 0 to 1023, sorry. So these are the kind of signal levels which Arduino can understand. So basically, what the sensor did, I will tell you 1 minute. Basically, basically sensor. The two types of sensor are present. Like one is a digital, and the second is the analog. Okay. What the digital sensors did? Basically, it provides only two input, either zero, either one, on the basis of activity and whatever kind of temperature sensor you used on that particular digital signals. Digital sensors has only two outputs. Okay, and the analog sensors, one sensor is like analog sensor. We will see, like it has output in the range of 0 to 1023. Like this is the overall range. Okay. So we will deal and see how these sensors are basically works and all. So just to give me a sec. Yeah. So types of sensors, like temperature sensors, I told you, like light sensors, which basically detects the light level, and the proximity sensors. So how many of you know about the proximity sensors? Can you tell me? Just open your mic and tell me. Do you know about the proximity sensors?
After a certain distance threshold is crossed, some certain action will occur. It is
Yeah,
proximity.
yeah, absolutely. Yeah, yeah, yeah. So basically, proximity sensors, which basically deals like object, how far your object, like what is the distance of your object from the sensor. So proximity sensors dealing in the such kind of situations, like say some motion sensors, some of you might have seen the PIR sensors, like and the right time, right this time, there's a kind of LED comes in the market, like auto motion detection LED. So means when you entered in the room, just light turned on. and if there's no person in the room, just uh, your
Non
light system will be turned off, right?
non-contact detection.
Yeah, non-contact detection, absolutely. So, yeah, and there's a gas sensors, like if you in the factories and all, if there's a kind of leakage comes, like any flammable gas start leaking, so these sensors will get activated and get told to the microcontroller like gas level is something like that, and if it is more than the threshold value, so microcontroller will start taking the action. It will make a, it will like play one, yeah. Sound sensors. Sound sensors basically detect the intensity of sound. Means when the kind of sound comes, like when you tell something, when you speak noisily, then sound sensor will get activated and all. Touch sensors, different kinds of touch sensors as well are over there. So we will see in the lecture. Okay, we will start upon the IR sensor. So the this kind overall looking of the IR sensor is something like that. Okay, this is our IR sensor. So you can see in the IR sensor, these are two LED. It's not, yeah, I can say it is LED. So first one is the IR receiver, and the second one is the IR uh, transmitter or emitter. And these are three pins over there, like VCC, ground, output, and the two status indication LEDs, and there is a potentiometer, which basically helps you for setup this sensors, means how how accurate it would be. It would be how sensible, means how much distance it would be sent. So these kind of things can be handled by this potentiometer. So first of all, we will coming upon the connection part. Okay. Here you can see the first pin is showing the VCC, means for the working of a sensor, we need power, because without the power supply, nothing is going to work, right? So firstly, we have to provide a plus 5 volt supply to this particular sensor. Okay. Then we have to provide a ground supply. Ground means negative voltage, right? And also we will provide now if the we want to take a signal output from the sensor, so we will connect this particular pin, which is known as output pin, to our microcontroller. Okay. And there are IR emitters, LED, and receiver. So what is the work basically? Do you know what is the work of this particular sensor? Okay, I will tell you. See, what's the work of IR sensor? Like you know that in the IR sensor you saw there's a two LEDs there. Okay. First one is IR transmitter, and the second one is IR receiver. What is meant IR receiver? Basically, what it is, the IR receiver basically, sorry, transmitter basically sends some infrared waves, okay, to the outer environment. If you put any object, if any object get contact with it, okay, see, if your hand like that, okay, if it is your hand, so what happens, these IR waves basically reflected from the surface, right? It is going in this direction, and it is when object comes, it start reflecting, right? When it reflected, so what happens, it goes in this particular direction, and here our second LED comes in the picture, not LED, it's a IR receiver, which basically detects the IR signal, which is coming after the collision of this IR signals with your hand or your particular body and all. Okay. if it detects like any signal is coming from any IR wave coming from the side, so there's a kind of current will be basically flows from here. Okay. If the current flows, there's a kind of circuitry over there like ICs and all. We are not going to deep what IC they use. So it knows that okay, means current is come from this side. That means there's a some IR waves comes to this LED, right? So sensor knows okay. Now any object come in the range of sensor. If it is happening, so this IC what it did basically on the signal pin, which is output pin, it provides a 0 volt on the signal pin. Okay, it provides a 0 volt on the signal pin. If it gets any object, right? So like this is your microcontroller, and this pin is connected with your microcontroller pin number 9. Okay, just 9. Anyone you can connect. Okay, see now what happens. If it is 0 volt, so we know that when sensor gives me the 0 volt, mean logic low. When any objects come in the picture, right? So as we get a 0 volt signal from microcontroller, suddenly just check, okay, this is a 0 volt signal. That means any objects can. And if it is knows the object can, then whatever task would you want to do, you can do as per the your code and instructions and all, right? Okay, now if there is a no objects, then what happens? If there is a no object, so what happens? See, if there is a no object, so these rays, infrared rays are going, no problem. Nothing is going to going to change their path in this direction. Right? No one is going to do this. If it is not something like that, so it will provide a 5 volt signal. If means logic high. Okay, so logic high. Okay. So two logic levels, either low, either high. When logic is high when there's a no object in front of the sensor, the logic will be high, your signal will be high. If there's any object come in the picture, then the object will be low, and sorry, object not the signal will be low, and happening is something like that. Okay, I hope it is clear to you. This is the story of the IR sensor, and I will just demonstrate some experiment also on the IR sensor. Yeah, 1 minute. Firstly, I will just tell you brief about the all sensor, then we'll start. Okay. Like same this flame sensor also there. What's the work of flame sensor? See, it basically detects the fire. In the fire, you know the various kind of rays are present. So it detects that particular range of rays. If it is find like okay, this particular frequency or wavelength rays is coming, so it knows that okay, it is from the fire, and it will send a signal. So see, here's the 4 pin. It's not a 3 pin sensor, it's a 4 pin sensor. Additionally, you will see the +5. Okay, you will provide a supply, then the ground, then the digital 0, D0. What is the meant for D0? Means if you want to take digital output from the sensor, means either high or low, right? So it will provide digital output on this particular line. Okay. In this sensor, if it detects any flame, so it will provide a 5 volt. Okay. It because it is an active high sensor. And either if there's a no flame, it will provide 0 volt signal on this particular pin. Okay. And there's a one more thing comes in the picture, like A0. What is the meant for A0? Basically, see, if it is your sensor, okay, and what happens at a some distance, like you have some fire, okay, burning starts. So digital pin will activated and give you a 5 volt signal. If you getting 5 volts, any active high signal, so you know that okay, okay, it's okay. The fire is started, right? There is a fire detected, but you cannot predict that how much intensity of the fire. Maybe sometimes fire will be very low, like not a very low means intensity of fire will be low. And if you place this particular fire like at this distance, so see now it is closer with your sensor, right? If it is closer with your sensor, so more fire waves will go there and it will be contacted with it, right? From here, lots of waves going this rays, sorry, rays and this. Some of only some of the rays are going there. So basically, analog's output here comes in the picture. What it did basically, and the fourth pin basically tell you, basically provide you data from the 0 to 0, 1 0 2 3. Means if fire is very very far away, so it will provide data in the range of 0 to 100. Means you can think like okay, the intensity of the fire or the distance of the fire from the sensor is low. If it is closer, some close, then you start from the 100 to like 200. See, and if it is very closer, then it will provide the data from the 1000 to 1000. So basically, analog in output will tell you about the intensity of the fire. Okay, how much the fire like where rays are coming from the fire and how much distance it has. Okay, the same thing like ultrasonic sensor. Basically, it's a sensor which deals with the that particular field where you have to uh, detect the distance of your object from the sensors, from your sensors and all. Okay, like you might have seen in the cars, like when someone is suddenly comes in front of the car, so they automatically brakes, the brakes will automatically activated and car stops, right? So who person is actually responsible for that particular thing? These kinds of proximity sensors are basically uh, responsible for that. Okay, so what is the sensor and how, I will tell you. Okay, so it's a proximity sensor. Okay, see, this are two things over here. One is ultrasonic wave transmitter, ultrasonic wave transmitter, and second one is ultrasonic wave receiver. So what happens in the previous IR sensor? You basically saw what it did. It sends like infrared waves, right? But it do something different. It sends some sound waves. It's a kind of sound waves from this particular device. And if any objects come in this region, Okay. So what happens? These particular waves get contact with this object, right? So some of them basically reflected over there. See, reflected over there. If it is reflected, then what happens? The second receiver will detect these reflected waves. Okay, and if it detects, then what happens? It will generate a signal, basically not to generate a signal, it will provide a signal to the microcontroller. Okay, now this is a high signal, like 5 volt signal. Okay, when microcontroller gets this 5 volt signal, then microcontrollers knows, okay, there's any object must be come, because without coming any object, this will not going to provide the 5 volt, right? On the free state means if there's no object is there, so it was only provide 0 volt. So with the help of this 5 volt signal, it can detect, like it can know, like if there's an object come or not. But thing is there, question is arises. It is only telling you that is there object present or not. It is not going to tell you how much distance of your object from the sensor. Like if it is a d distance, so it is not going to tell you like how much distance. It is just providing you a signal. So we can do such manipulating techniques, like we can do some kind of thing. I will tell you what the thing we are basically did for the getting the distance of the object. Okay. Step one. First, we will send in the first step. We will send a wave. Okay. For the 10 milliseconds. For example, 10 milliseconds, like 10, 12, whatever you want. Just I'm taking example of 10 milliseconds, and then stops. Okay. So what happens? See, like for the 10 millisecond, okay, this will be your wave. Only this part. For the 10 milliseconds, for example, this amount of wave will be generated. Now, step two. Basically, we used a function which is known as pulse in, basically which start a timer inside a microcontroller. What it did, it basically counts, it start counting the time till whenever it got a high wave on that particular pin. Which pin? Basically, which pin is connected to this signal pin. Okay. So it start a timer. Okay. Listen carefully. Waves, 10 milliseconds wave is there. Okay. And after sending this wave, it start counting. Okay. Wave go like this. Okay. For example, if there is an object, get contact with it and just pulled back. Okay, it's a not continuous, but just only this amount of wave. Okay, only this goes and turns off, turn back. So it will detect as this waves comes to this sensor. Basically, it sends a signal of 5 volt, right? As it get 5 volt, it stop counting, and for example, the time will be like 20 milliseconds. For example, I'm not accurate, just for the example. So what we have right over here, we have time. Okay, and we also know the speed of ultrasonic waves. like sound. It is kind of sound wave, so we will consider as 320. I think something like not actually no that is like 320 or 250
343.
something like. Eh?
343.
23 okay 320.
343.
So okay, 1 minute. 343. Okay. So we have time, we have speed, and we know the distance is equals to speed into time. Just after doing some calculations, microcontroller can easily get the distance. See. So by this way, we can get the distance of the object from your sensor. Okay. So I just go some deeper in this particular part, but okay, no problem. So yeah, this is overall thing. And see on the pin diagrams of VCC, like we are providing the plus 5 volt, and the ground you will provide a ground signal and a trigger basically which for the sending a wave from this channel from this like what is transmitter. So you have to put a signal over there, and if it detects any wave, so output signal will be here, okay, on the echo pin. This is a kind of microphone sensor. Same thing, if it detects any audio, and also it will provide a signal in the form of digital, and also it will provide a form of analog, right? Analog and digital as well. The LDR sensor, like it will detect the light, right? And on the basis of the light sensitivity, it will provide a digital signals. Like it have only the two levels, like either zero or either one. And there's a touch sensors, and so many more kind of sensors present over there, like PIR sensor. Basically, PIR sensors is responsible for you might have seen some LEDs when the person enters in the room. The LED will basically turn on and off. So these sensors are basically responsible for that. RFID card sensors, which basically reads the RFID cards, right? And some smoke sensors and gas sensors. And this is accelerometer sensors. Not accelerometer. This one is a gyroscope sensor. And atmospheric pressure sensors. So it will detect the pressure of the atmosphere. Barometric pressure also you can know. So these are kind of sensors over there. So now we will start our practical aspect on the sensors and all. So I will just pause this screen, and I will just. Kshitij bro, can you just pin the my second
Okay.
video, please? I
Okay.
logged in with my another device.
You are mute.
Yeah, give me a second. I think voice is clear, right?
Yep.
Okay, sure. Just give me a second. See, my voice is clear, right? Okay.
Yep.
So, as we saw in video and our session, these are kind of sensor present over here. This is basically uh, ultrasonic sensor. which I told you, and this is your touch sensor, which basically detects when you touch over here. It will provide a signal from this particular pin, and the Arduino knows, the microcontroller knows what the thing, what's the things are going to happen over there. Okay, and now we have some microphone sensor. See, it's a small microphone was embedded over here, and this is the potentiometer. I will tell you what the work of potentiometer. Basically, with the help of this potentiometer, you can adjust the accuracy of your sensor. Means how accuracy not a good word. It's a sensitivity, I can say. Like how sensitive you want a sensor would be. Okay, and we have some more sensors. Like, this is the basically flame detection sensor. Okay, which basically detects the flame and all. Okay, and see, in the flame sensor, basically these two pins for the supply and ground, and this one is for the A0, where the written is A0. A0 means it will provide an analog output of that particular point, okay, or that particular pin. And if you want to know, I don't want to take any analog input, I just want to know that either fire is there or not, just in the form of digital, like either high or low. So you will connect from the D0 pin. It is written over here. Camera is not able to capture such small things. So when you deal by yourself, then you will see that there's a D0 pin here. And yeah, this is basically LDR sensor, which basically detects the intensity of the light. In the street light system, automatic street light systems, this sensor is basically responsible for the sensing and all. And we have some infrared sensor for the object detection purpose, as I told you. Okay. And we have some smoke sensors over there, smoke and gas sensors. This is the smoke and gas sensor. And yeah, this is a PIR sensor. As I told you now, when someone enters in a room, it basically notes. Basically, each and every human body radiates some waves, some raises in form of infrared. So what this sensor did, it basically detects that particular rays which is coming from the human body. If it gets that particular rays, so it will provide a signal from here. The what is the signal? It's a high signal. That means okay, anyone comes in a picture now. Microcontroller, over to you. Whatever you want to do. Okay. Some more sensors, and not a sensor, it's a joystick module like thing. Yeah, we can say it is sensor because it is basically sensing that if you push it forward and backward, left and right, it senses that which direction is there. So there's a kind of potentiometer connect over here. When you press, not a press, when you pull it forward and back it in the reverse direction, so what happens? The potentiometer moves. Okay, if the potentiometer view moves, the resistance of the potentiometer will be changes, and the resistance of the potentiometer changes. So the change of the resistance, there's a circuitry which detects the change of the resistance, then it knows that okay, something is happening, then sends the signal to the microcontroller. One more sensor is like a soil moisture sensor. You saw in the farms and all. In the India is not a quite popular, but yeah, in the foreign countries and other countries it is quite popular. Like what it did, what this sensor did, it you just take it and put it in your soil where you are basically mm, one minute. Oh, okay, sorry. Yeah, where I am. So basically, it when you take it and 1 minute. Okay. Okay. Just give me a second. Actually, shoot. It's a power issue there. Actually, my laptop charger is not working. So, okay. So in the soil, it detects basically moisture of the soil. Okay. On the basis of the moisture means how much moisture is present in the soil. It sends to the microcontroller. Okay. So on the basis of this particular signal, microcontroller knows that water is needed or not. Means if your soil is very dry, or if it is very dry, so it will activate the pumps and put it the water and all. So these are various types of sensors. And, we will see some sensors and also demonstrate some experiment over here. So I will start with this infrared sensor. Okay, I will just make a program which basically detects any objects. So I will place it on the breadboard. Okay, and Arduino microcontroller. That's bunch of jumper wires. Okay. Okay. So yeah. See, middle pin is the ground, so I will connect black wire. VCC, I will connect red wire, and the third pin is the output. Okay, I will connect it. This is my microcontroller. See, I will connect this plus supply on plus 5 volt of the Arduino. See, and black one from the ground. And this is our signal pin, right? So whatever pin you want to use from the 0 to 13, you can use. So now I will share my screen also. So you can get these ones. Okay, so I hope it is visible, right? Just show me your reaction, guys.
Yeah, it's visible.
Okay, so I'm just putting Arduino ID. Yes. Okay, so everyone will familiar with this Arduino ID interface. So first we will decide that which pin we are going to use for getting this signal. Okay, so if we are using any pin, so what we did is firstly define it, pin mode. Like which pin, for example, I am just using pin number 8. Okay, so pin number 8 and as a input pin. Okay, previously we are using these pins as an output mode, but now we are using as the input pin. So basically, we will also show the status, like if object is there or not on our serial monitor. So for the activating the serial monitor, what we did firstly begin our serial monitor, serial.begin with the 9600 baud rate. Okay. And it is, and our setup portion is completed. Now enter in the loop portion, which is going to happen infinitely, right? So basically, we will read a data, right, from the sensor. So see, For the reading the data, it's a basically we are using the digital form, right? So we will in the digital form there's only two options, right? Either zero, either one. So we will make a integer which is data is equals to for the reading data from that particular pin we generally use digital write. We use okay, sorry, digital read. Digital write is used for the writing it, digital read. So it asks you about two parameters, means not two parameters, only one parameters, but which pin you are going to read. Okay, so we connected our sensor at the pin number 8, so we'll tell you, okay, I'm using this pin number 8. Okay, then we will print this data. Okay, serial dot print what we are going to print data. Just a two lines of code. After the- So let's see what happens. First we will compile it. Okay, and just going to plug this Arduino with my PC. Okay, so just I'm going to upload this sketch. And I will connect this signal pin on the pin number A. This is the pin number. Just open the serial plot. See, right now in the serial monitor, I think it is visible for you. 1 1 1 1 1 1 is showing. What does that mean? Means right now sensor is sending you 5 volts output here. And this in the previous 1 minute, yeah. Bias. Okay. So I told you when there's a no object is there, so this sensor basically sends a 5 volt signals. Means it is a active low module. Means active low means it will send a low signal, 0 volt signal when it gets any object. So right now it is 1 1 is coming. And what happens when I place my hand over there? See, as I place my hand, it is showing 0 without contact. See, suddenly change to the 0. Are you seeing, guys? This is my hand, and as I take it closer and closer, it detects and starts showing 0. See, and if I just remove my hand, it is 1 1 1 1 1 1 1. Again, see. So by this method, you can set up your sensors and all. Like if you want to do some implementation on it, you can also do it like this. So we don't want a 0 and 1. We just want like if there's an object, so it will send me message. Okay, object detected. Otherwise, no object. Okay, so what we will do? We will set if data is equals to like 1. Okay, so it will print when data will be 1 when the signal is high, and when signal is high when there is a no object, right? So it will print okay no object detect object. Okay, I make a just and I will also do one more if statement. Sorry. And if data is equals to 0, okay, then object will detected, right? Okay, just change. Okay, and I will just remove this particular line. So now I don't want to see any data 0 and 1. I just upload this. Okay, just upload it and upload it. Right now it is showing no object detected. Okay, just I place my hand over there like object detected. No object, object detected. Okay, so we can do some more things with this. Like if what we think when object detect. So I just want this will be LED which start glowing. Okay, like it will tell the status of that particular LED will tell us okay there's a person or not. So let me take LED.
Can I add one thing?
Huh?
Can I add one thing?
Sure, sure.
Okay. So if you are using this type of sensor where
Okay.
digital signals comes, okay. So you don't need
Okay.
microcontroller. Just connect the power and
Yeah,
where
yeah.
in the data pin you can receive 0 and 1. You can use in your circuit.
हाँ
Okay.
हाँ बिल्कुल बिल्कुल बिल्कुल
And and that fire sensor or some mic sensor and some that sensor like LDR sensor you can use without microcontroller. Okay.
yeah yeah yeah. I think you are familiar with these sensors and all.
Yeah, yeah.
Good,
I
good.
made a lot of projects.
Okay, okay. Okay, just give me a sec, please. Okay, get it. And I think this is right. Yeah. And, for the ground supply, I connected it to the ground. Okay. And
So for the
the
controlling
second
speed you
pin.
can add a delay in it. Okay. So
Huh.
just
Okay.
add delay
So now,
and your code will be stopped for that. Okay, continue. Yeah.
yeah. Okay. Thank you. Thanks for adding this. So, what our goal over here? Our goal is see when object detects this light will start glowing. If there's no object, the light will turn off. Okay. So what we will do? Firstly, we will tell the microcontroller like, okay, I'm adding one more feature with you. So I'm using one more pin. Just in the setup part, tell you about the pin mode. Okay. Pin mode. What basically you tell the which pin you are going to use. Like for this, I'm using 7 number pin. Okay. So what purpose? As a output. Okay. I just tell them. Basically, I just have to add one current limiting resistance of 220 ohm, but right now I don't have, so I will just doing it. But when you do, just try to bring a current limiting resistance also because it will basically affect the overall life cycle of the LED. Okay, so this will be the output. Okay, I just defined it. Everything will be same. Now what we are going over here, just is changing some line. Like if data is equals to one son, what is happening over there? Like no object. Okay. This is the basically comment, so you can add anything. If your code is very messy and very long, so these comments will basically very helpful for you for finding that which function and program corresponds for which part. So inside the if statement, what I did, if the data is equals to one, serial println will print okay, no object. Also, what we will do, we will write on that particular pin. What we write, we are going to write. So digital write. Okay, what we are going to write? We are firstly we are going to tell them about the pin number. So what's the pin number? The 7 number. Okay. What we are going to write over here is the, because low signal is getting from this side, and if we provide again low signal, so LED will not glow. We will provide low. Okay. So when no object is there, it will be turned off. And if object is there, so we will provide just a high signal. If it is high and other side is low, so LED will start low. Right? And yeah, our code is ready. And let's compile it first and upload and see what happens. Oh, and we are going to come. Okay. And I'm just going to connect it from 7. See, now there's no object is there, right? And if I place my hand over there, just see, object detected and LED start glowing. I think it is not clear. Let me turn off this light so you will see clearly. Okay, this is my hand. I'm placing it. Okay, object detected. No object, object detected. Light also start blinking. Okay, you can see. So this is the working of your, 1 minute. Yeah. Infrared sensor. So by this simple lines of code, you can easily operate your sensor and whatever task you want to do, you can easily perform. Okay. So also now we are coming for the testing of our this flame sensor. Okay. So now I will tell you about how the flame sensor basically you can 1 minute, let me remove this sensors and all. So 1 minute. Just guys tell me it is clear all of clear with you or not? Are you getting?
What is the difference between ultrasonic sensor and IR sensor then?
Sorry.
What is the difference between an ultrasonic and an IR sensor?
So,
What is the noise is not clear? What is the
for ultrasonic sensor is can work in dhoop, sunlight. Okay, this type of sensor cannot work in sunlight, and you can buy a separate one which is called ultrasonic sensor has wide range. Okay, 2 meter of range. You can buy one which has 2 meter range. Okay, and this sensor
basically?
is has short range.
Yeah. Ultrasonic sensor has a long range. Okay, and this IR sensor basically not a long range such time. Okay, so now we are moving forward on our second part, like demonstration of this flame sensor. Okay,
Yeah, okay, yeah.
okay. Are you?
Yeah,
Are you?
yeah, yeah.
Yes. Until this one, give me 1 minute. Okay?
Okay, okay. So, guys, uh, so do you have any idea how can you create own sensor? Do you have any idea?
You need to have a input and output destination as well as the ground and some transmitter and a receiver along with some chips that can use to process the particular information that is coming
No, no,
from
no,
the
no.
transmitter.
Let me give you two things. Just take this LDR and 10K register, connect it and make a sensor. Can you? Or give you a switch and 10K register, make a sensor. Have you studied about potential divider circuit?
I think they are basically from the data science background.
Yes, we can make.
So, in let me tell you in very simple terms. Okay, so for potential divider circuit, you have to add 10k resistor and some like single thing. Okay, add a LDR or switch or IR receiver signal and so many things. Okay, uh, IR receiver LED. Okay, so just add one terminal of us. Like you made a circuit like one resistor is here and okay, wait a second. So, am I visible? Okay, so just think like uh, this is 10k resistor and I'm taking another 10k resistor. Uh, think like this a 10k resistor and this is a switch. Okay, just connected. Okay, so you have a node and two terminals. Okay, so just connect one terminal to the 5 volt and another terminal to the ground. Okay, and the node you have to pick the signal. Okay, so you can get the signal between 5 volt to 0 volt. Okay, you can make your own circuit, your own sensors easily.
Okay. So I think we start
Are you
continue this
ready?
discussion. Yeah, I'm ready.
Okay,
So
continue.
I just connected the wire with this sensor like plus 5 volt and minus this power wire is going in it's a ground wire, so it is going on the ground and the VCC on the plus 5 as we did previously. Nothing new here and this is the ground and this is the 5. Okay. Now in this particular sensor, what we are doing in previous example, we deal with the digital signals, right? The output in the form of digital. Now, in this example, in this sensor, we are dealing with analog output. Okay. So this particular blue wire is connected with the analog analog output signal. Uh, I will take it from this is our okay. So program I have is see. First of all, we will don't see upper part. See, firstly, we will begin the serial monitor and all for the communication purpose. And here you will see I declare int sensor value. Okay. What is the int sensor value? Int sensor value is equals to analog read. Analog read is a function which basically reads the analog data. And if you are dealing with the analog data, so analog data can be read by only these 6 pins, A0 to A5. See, here you are getting the 6 pins. You can deal with analog data only over here, not everywhere. Okay. So see, these wires are these pins are basically digital and these are for the analog. So what we will do, I will use A0 pin as sensor output. Sensor output. One thing you have to remember that for the analog read, if you are using the analog pins, so you don't need to put over here like pin mode, because pin mode we need when the pin can generate an output and get an input as well. But these analog pins only have one functionality. It can only receive the analog signal. It cannot, you cannot write or generate any digital or analog output over there. These pins only read the analog data. So there's no need of telling the microcontroller which we are getting input and output, because it's only input pins. We cannot get the output from these pins. Okay. So let me get out this page. So in the sensor value, we will basically get the data and analog. See, first line is reading from the analog sensor, and second line is printing like analog value. Then what's the value is sensor value. That what we are getting from the sensor. Let me first compile it. Okay, and I'm going to upload it. It is showing some random values because right now wire is not connected. I will connect this wire.
Utkarsh bhaiya,
Hello.
yeah, analog pin can write also.
No, no, analog cannot write. I think it cannot. Just check it on the internet, but I'm sure that it cannot able to write.
I used.
So you use the PWM thing. Huh?
No, 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 no. Analog pin.
Okay, we will see it, but one thing it can write. Okay, we will see. Okay, so for the testing this particular IC, okay, sorry, not IC, the sensor, we have to take some flame. So I'm just going to turn off my fans. Okay, just give me a second. Okay, are you? Yes, very fast. Okay.
Yeah, yeah.
Done.
So, how can you use this flame sensor without Arduino? Can you tell me?
Can you repeat the question, please?
Uh, can you how to use this flame sensor without Arduino, without any microcontroller? Have you any idea?
Like you just say, we can use one resistor and then connect a reading pin between the resistor and the IR and one positive and negative.
Okay, here is three pins. One is ground, and one is VCC. We have to connect it. We can take external power supply with any charger, and we can regulate it and connect it. Okay, and for one pin like data output, you can connect any LED or any relay switch. Okay, so you can add that thing and you can use it without any microcontroller. Okay, of course, continue.
Okay, so I'll continue. Just open the serial monitor again. See, it's the serial monitor is right now showing some random values, and I have some matchsticks over. And let me turn off the slide so it would be more clear. Okay, so I just make a flame. Okay, see, as there is a flame, data is changing. See, if it is coming, it is very close, so it is 19, 20. If it is some far, 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 440, sorry, 300, 400. And if it's more far, now it's something like 700. And it is close, if it is close, oh, it's a 20 and all. Let me do it again. See, see the data, 30. If I'm removing it, not removing that, place other side, yes. Okay, see. So basically, analog data will also tell you the how much intensity you are getting from that particular thing and all. So yeah, we can manipulate some more things with like if we want this LED will be glow when the flame is coming. So just that statement of the
Okay, change the
data.
code. So, uh, if you are using this type of sensor, which where is values are changing so quickly, and you want to read the certain exact precise data. Okay, like fire is there or not there. Okay, so fire blows like left, right. Okay, so you have to read the data for long period, is fire is there or not. So read the data and save it and then average it. So that will be a good idea. Okay,
Yeah, yeah,
use that.
okay, absolutely. This is a good idea for the more accuracy.
Yeah.
If you are using it for the some industry purpose and other all purpose which you have accurate reading, so these things will be
Okay, you complete your
matter.
code
Okay.
and I will continue the process. Connect now.
One. Okay, so if the value is high, like 900, so okay, then it means there's a no flame, right? So not a 800, I believe. Okay, 900 is and just what a right. And pin number we are using for the LEDs. Okay, it will do as we did in our previous code. And we the sensor values and it will have. Okay, and we have to do one more. Let's spin mode. Present in and okay, just compiling this sketch. Building. Okay, it's a compiled and I will upload it. You can see the monitor. Like this value are coming and connect. I'm going to connect it. Ground, and 7 number pin. No, okay. Every connections is ready and let's test it. We have some flame. Okay, see, as it detect the flame, LED gets turned on. There's a no flame, no LED turn. If detects a flame, LED turn on. No, either on, either off, right? And if you want, like, okay, we don't want like on the 900, like if you want more precise, so we do like 100. So if we will change it 100, so now sensitivity will be more high. So let's see what happens. Okay, it start and right now it is detecting when very close with it, right? If it is not, then this kind of thing happening. Okay. So yeah, guys, this is the overview of that particular sensor and all. So, Hariom, Hariom, are you there?
Yeah, yeah.
Yeah, just handle it for a minute. I just turn on the fan. So,
So, are you leaving now?
No, not leaving. I'm just turning on the fan because I just all turn off the fan for the flame sensor, right?
Okay. So, do you guys want to continue the sensors or something else apart from these sensors? Hello, am I audible? So, what do you guys want? Sensors or something else?
Something else
Both
means what?
options.
Uh, and our ESTC lab or EEC lab in our course, like electronic system, use ADLAB 1000. Do you want to understand how it works or how to use it?
Okay, okay.
Yes,
Oh,
please.
so
So, 1 minute, let me ask some questions. So, guys, are you getting these points? Are you get enjoyed this class or not? Firstly, tell me this. Okay. Yes, sir. So, yeah, okay, okay. So,
yeah, Sanjay, what's your doubt?
yeah. Okay, ask me out if you have any doubts. You can ask me. No problem. If you have any suggestions and all, we are happy to listen to you.
Sanjay?
Okay.
Okay,
So I
Utkarsh
think,
Bhaiya,
huh?
there is one doubt in the doubt which says like is potential divider equivalent to voltage divider bias
Yeah,
of
yeah, yeah.
CE configuration? Actually, I don't know the basis bias of CE. What is this? Like bias is connecting, and what is the CE
Where's the question?
in the comment? Actually, I don't know the CE. What is the meaning of CE? So common emitter. Okay. So I guess that's the same thing.
1 minute. Okay. So
So
it's a time to, I think, end this class, and I hope guys will enjoy this class. And yeah, Hariom, you can carry on.
yeah. So so do you want to learn about Adlam 1000 or should we end this meet? Or we continue in another video in another
Yeah,
session?
it's 8:30, and it's a 5 minute Q&A session. If you have, guys, you have any doubts and queries, so we are here, and then onwards at 8:30 we will close the session. Okay.
Yeah. Yeah, yeah, Sanjay. Brijesh, what's your doubt?
Uh, I'm audible.
Yeah, yeah.
Yeah.
Uh, how ultrasonic sensor convert electrical signal into ultrasonic wave? Can you explain?
Sure. There's a kind of oscillator is there, crystal oscillator kind of thing. When you learn about the internal structure of the, I will just tell you. It's a quite deep part, but it's a kind of oscillator are there. Okay. It is your ultrasonic sensor. Okay. When see, for the generating the ultrasonic waves, what's the waves? Basically, waves that which like a sound waves like things, right? Is the kind of vibrations. So inside this particular transmitter, what happens? There's an oscillator, which is very macro. You cannot see by your eyes. Oscillator, like I will tell you in the easy way, like a thing. You saw a bell. I think you saw a bell in temples and all. So what happens in a bell? You just manually push the bell and then a sound wave generated, right? The same thing happening over here. You have a device, okay, and it will be some of them are using the magnetic field, some are using others. So like this is your metal plate like thing, okay, and this is your magnetic field, like anode and cathode. But here you will get plus and minus. So what happens? The some companies. This is the not proper way, proper structure, but yeah, it is quite similar. That I will tell you how the oscillations and all. So we will change it polarity alternatively. Means firstly it will plus, then minus, plus minus. So what happens if it is plus? So
Yeah.
electric field
Yes.
from the
Utkarsh bhaiya, are you like presenting anything? It's not visible.
Screen is not
Oh,
visible.
sorry. Okay, sorry. I will just forget it. Sorry. My mistake. Okay. 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 Is it visible?
Yeah, yeah,
Hello.
yeah, yeah,
Is it visible right screen?
yeah, yeah.
Yes, visible.
Okay. Oh, okay. I just forget to present it. Okay. See what happens. This is I'm again telling you. This is your ultrasonic sensor. There's a trigger, transmitter, and the receiver. Basically, this kind of structure present over inside the this transmitter. So it if firstly on this plate, if for example you have a plus 5 volt and this minus, so electric field direction will be in this side, right? So force on this, like if it is a charged particle like magnetic field, I think, so it will act on this particular side. So it, as it goes in this direction, you change the polarity, it just comes back, then it goes, then come back. It is happening in a such a speed way, so that it will generate us waves like thing. So by this technology, by this technique, you can generate
Connect them with
uh,
the speaker.
this. Yeah, as these things happening in the speakers and all. Okay. Any other queries?
We are learning C programming. Uh,
Okay.
it will be problem for Arduino programming because
Problem.
Arduino is C++. For
No,
Arduino,
no, 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 no. Don't think that. C plus plus. There is some very when you go in some deeper thing, then you will get the some C plus plus concept like object. Because in the C language you don't have any object function, right? If you are doing such a kind of project, then you need a C programming. But otherwise, it is similar to the C programming. The almost the syntax and all it is quite similar. So you don't think that you don't know C plus plus. So it will difficult to know. It is the similar type. But the thing is, you have to practice. You have to think. You have to think that how what kind of work you are doing. What is the analogy of that particular work? Firstly, you will think that on that particular task, what thing will be responsible, right? Like as I told you na, on the flame sensor, as the fire comes, right? Session over, yeah, you can,
Yeah.
uh, it's over. uh,
So
so you have to think that aspect and then sort out that what the things I have to do, then program your overall idea or structure as that particular way, then write a proper code with your
yeah, yeah. So Arduino Uno has different syntax also. So you can use Python with the VS Code.
yeah,
Then you connect with the US
micropython,
like MicroPython. Yeah. So you
micropython.
can add with the VS Code and use different languages. Well. You have to like need some what is that word? I forget that word. Uh, Converter. No, no, no. Interpreter.
Compile,
compiler.
Yeah,
interpreter, okay.
that's one.
Uh,
So you can use
basically,
different
when you
languages.
when you program a microcontroller, so your C language or C++ or MicroPython language is not going to place inside this. What happens, the compiler firstly sees your program, that what you are right, then it will compare with their own functions. Okay, see, every function, like in the Arduino, like you use the digital write pin. So in the directory of Arduino IDE, there's a place where the all the things are situated. So compilers go that particular directory and then check what it means for the digital write. Then it converts this particular code to the machine language, like in the form of 0 and 1, like a binary language. Then particular code goes in the microcontroller. So if you are using the Python, the same thing happening. Now your compiler will check, like with other function, like if you are using MicroPython. So in that, I think pin mode is not there. It is write function, if I'm not wrong. There, so happening these kinds of things. So don't think about programming and all. It's easy. But yeah, if
Oh,
you are initially the first person, then firstly you are going to learn these kind of things. So prefer Arduino language. It is easy and widely supported, right? Because
okay.
max of the sensors have different libraries. These are the basic sensors. Okay, if you are dealing with other kind of like accelerometer sensors, gyroscope sensors, like transmitter sensors, so they basically have their own libraries, because it's a very basic. I'm just telling you, it's not advanced. It's a very basic sensors. Like you can control it on the 2 to 3 lines of the code. It's not very advanced. So if you are doing the such kind of thing, which is basically very high, so you need some kind of like libraries and all. So I will show you, like this is the very basic. 1 minute, I will show you some advanced project as well.
So when you know any one language in like a proper manner, then you don't think about like other learning in any problem in other language. When you switch to other language, it's so like
Okay,
lot
but
of things are similar, but just syntax is changed. Okay,
Yeah,
okay. Thank you.
I will just show you 1 minute.
so you can find examples as well here, and
Yeah, no, no, yeah. It's lagging something. Let's wait for a minute. Yeah. See, it's my program for I'm designing for controlling a RC plane. Okay, like getting a signal from the transmitter and provide this signal to my Arduino, and not Arduino. I'm using that right a different board. So on this particular board, then what I did, on the basic of that signal, I basically manipulate some things, like if my drone is coming downwards, and if what happens, like if it is coming downwards and suddenly object comes, so these things will be managed, like okay, if object comes, it don't maintain their height. Okay, so updating it, so I make this particular lines of code and this one. Yeah. So see, it's a light, like I use the ibus.bm library, which basically helps to communicate with your, like if you are using a transmitter, like FlySky is a quite popular. So if you are using the FlySky transmitter, so FlySky transmitter has the option, receiver has the option. You can get these particular data, what what the transmitter is sending to on a particular DIY board and all. So this is library as called that. So basically, what I did, I just read the each and every channel's data, then do some manipulations, like see, here is the like for loop and also what is it reads all channels data, because in a drone and also there's a lot of channel, like throttle, yaw, right? elevator, aileron. You have to maintain these particular things also. Like you have to set your flying mode, like you are using which flying mode, like altitude hold mode, ladder mode, glider mode. So these data will be communicate on the different channels. So this is basically for the concern for the like reading channels and also you can see like if you are dealing with a large extent of projects, some heavy projects, so you need some kinds of library as well. So overall, the thing is you have to do some practical work on with it. Then you will get these things, and it is quite interesting. Not a tough if you are doing it, so it will give you lots of enjoy and lots of learning. Okay, so I hope today's session is helpful for you.
So
Yes, thank you.
if we have any doubts, so we can end the session.
I
Sure.
have one doubt more.
Yeah,
Okay,
Uh,
okay. Ask.
Actually, I am comfortable in Hindi. Can I ask in Hindi?
yeah.
बिल्कुल बिल्कुल
Which
बिल्कुल आप
type
बिल्कुल
of
Oh,
spatial
thank you.
signal generator?
बिल्कुल बिल्कुल
भैया मुझे थोड़ा इलेक्ट्रॉनिक्स में इंटरेस्ट था और उससे ज़्यादा मैं बहुत दिनों से काम डिस्प्ले में कर रहा हूँ, जॉब करता हूँ तो मुझे टीएफटी टेक्नोलॉजी में ज़्यादा इंटरेस्ट है। तो ये जो हमारा बीएस डिग्री इलेक्ट्रॉनिक सिस्टम में है, ये कितना हेल्प करेगा मुझे टीएफटी का टेक्नोलॉजी को अप्रोच करने के लिए?
टीएफटी टेक्नोलॉजी बोले तो आप कहना चाह रहे हो जो डिस्प्ले लाइक जैसे हमारे कंप्यूटर लैपटॉप्स की स्क्रीन है उसमें राइट।
हाँ, मैं
हाँ तो
उसमें
बिल्कुल
सर।
हेल्प करेगा। हाँ बिल्कुल बिल्कुल हेल्प करेगा, बिल्कुल हेल्प करेगा, इसमें ऐसा नहीं। देखो टीएफटी टेक्नोलॉजी में व्हाट क्या चीज़ें होंगी लाइक देखिए पहली चीज़ तो एक पावर सेक्शन होगा जो कि पूरी टीएफटी व्हाट इज दैट टीएफटी बेसिकली टीएफटी में बहुत सी एलईडीज लगी होती हैं। अब
हाँ।
जैसे राइट नाउ सुपर एमोलेड आ गई है
हम्म।
टेक्नोलॉजी सुपर एमोलेड। तो सुपर एमोलेड डिस्प्ले क्या करती है कि ईच एंड एवरी पिक्सल हैज बीन रिप्रेजेंटेड एज अ एलईडी। ठीक। तो उसके अंदर बहुत से वेरियस एस्पेक्ट हैं लाइक आपको पावर की मैनेजमेंट भी करना है। ठीक है। कंट्रोल कि लाइक कितनी देर पे कौन सा सिग्नल काम करना चाहिए। तो एम्बेडेड सी आपको बेसिकली बहुत हेल्प करेगा क्योंकि बेसिकली जितनी भी एलईडीज होती हैं, जितनी भी पिक्चर जो आप सराउंड करते हो तो मैट्रिक्स फॉर्म में बनती हैं। ओके। सो मैट्रिक्स फॉर्म में अगर डाटा बनता है तो उसको हैंडल करता है बेसिकली एक माइक्रो कंट्रोलर। सी इसको हैंडल एक माइक्रो कंट्रोलर ही करता है। तो आपको ये चीज़ बहुत हेल्पफुल करेगी कि समझने में कि माइक्रो कंट्रोलर कैसे बेसिकली डील कर रहा है। मेरा एक्चुअली प्लान भी था कि एक इस प्रकार का प्रोजेक्ट करूँ आप लोगों के लिए लाइक मैट्रिक्स डिस्प्ले मतलब छोटे इन छोटी छोटी एलईडी से अपना एक डिस्प्ले करने का एक दो तीन चार इस टाइप के डिजिट बट उतना समय नहीं हो पाया तो अवेलेबल नहीं हुआ। बट हाँ तो उसमें तो ऐसी हजारों और लाखों डिस्प्ले लगी होंगी, सॉरी
वो
एलईडी लगी होंगी बहुत सी। तो उसको कौन मैनेज कर रहा है?
वो
उसको मैनेज कर रहा है माइक्रो कंट्रोलर।
हाँ, वो पिक्सल्स होते हैं उसमें, पिक्सल्स में सब
हाँ
पिक्सल्स
वही
होते हैं।
वही। हाँ वही
हाँ।
वही 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 बोल रहा हूँ वही बोल रहा हूँ। तो वहाँ पे आपको एम्बेडेड सी हेल्प करेगा, बिल्कुल हेल्प करेगा। पावर के लिए मतलब जो लाइक पावर सेक्शन है उसमें लाइक बहुत सी चीज़ें आप जानेंगे। जैसे टीएफटी में क्या होता है, आपने 220 वोल्ट की सप्लाई दी। ठीक है।
हम्म।
आप जानते ही होंगे कि टीएफटी बेसिकली या तो 5 वोल्ट पे काम करेगी या 12 वोल्ट, यही या 3.3 ये
हाँ।
रेंज चलती है।
हाँ, तीन
तो
पॉइंट
पावर
तीन एंड
सप्लाई
पाँच
आपके स्टेप
बारह।
डाउन ट्रांसफार्मर में है राइट। स्टेप डाउन पे
स्टेप
आ रही
अप,
स्टेप डाउन ट्रांस।
स्टेप अप, स्टेप डाउन, डीसी टू डीसी कन्वर्टर थ्रू।
हाँ नहीं नहीं डीसी टू
हाँ।
डीसी नहीं, पहले तो स्टेप डाउन किया उसने 220 वोल्ट एसी को। ठीक है।
हाँ।
वो हो गई आपकी लगभग 12 वोल्ट। 12 वोल्ट के बाद वो ब्रिज रेक्टिफायर में गई। ब्रिज रेक्टिफायर बेसिकली क्या करता है कि मतलब जो हमारी आपकी करंट आ रहा है उसको डीसी में बना दिया। फिर
हाँ।
उसके बाद आप देखोगे सर्किटरी में एक कैपेसिटर लगा होगा जो कि फिल्टर आउट करता होगा जो
हम्म।
अनवांटेड नॉइस है। ठीक है।
हम्म।
देन उसके बाद डिफरेंट सबसेट्स में चली गई। मान लो माइक्रो
कंट्रोलर के
कंट्रोलर
लिए,
में जाना है
बैकलाइट के
तो
लिए।
5 वोल्ट तो
हम्म।
हाँ हाँ तो वो 5 वोल्ट वाली सेक्शन में चली गई तो LM708 लाइक रेगुलेटर्स लगे होंगे। 12 वोल्ट के लिए रेगुलेटर्स। तो ये चीजें आपको बिल्कुल हेल्प करेंगी।
ये सारी चीज़ें तो मैंने थोड़ा सा ऑलरेडी मैं थोड़ा सीख चुका हूँ। लेकिन
हाँ
नहीं, इतना नहीं कह सकता कि डीप से सीखा हूँ, लेकिन जो भी ओवरव्यू है मैंने उसका देखा हूँ। मुझे एक्चुअली वो VLSI जो होता है, TFT मैन्युफैक्चरर टाइप का, उस टाइप का मैं कोशिश कर रहा हूँ। अप्रोच करने के लिए
तो
फ्यूचर में कि मैं
वीएलएसआई आप
समझ
ऐसा
रहा
कर
हूँ।
सकते हैं, एक बार अभी जल्दी में प्रोफेसर से बात हुई थी, तो वो कह रहे थे कि इलेक्टिव कोर्सेज में शायद चांसेस हैं कि वीएलएसआई से रिलेटेड टॉपिक्स को इंक्लूड किया जाएगा। तो आप जब सेकंड थर्ड ईयर में अपना इलेक्टिव चूज करिएगा तो उसमें देख लीजिएगा जो कौन से वीएलएसआई के क्लोज टू हैं। ओके,
हम्म।
तो आपको मतलब ज़्यादा इन्फॉर्मेशन और नॉलेज मिलेगी।
भैया
हाँ,
16+2 दिखा दें क्या?
सॉरी सुन नहीं पाया।
16+2 डिस्प्ले, लाइक कल एलसीडी डिस्प्ले
कल
16+2।
ओके ओके, अच्छा 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 अच्छा, 16x2 हाँ चाहो तो दिखा दो, बट मेरा कल सेशन लेना मुश्किल होगा,
नहीं नहीं।
मुझे थोड़ा और काम है। सो
हाँ हाँ।
आई थिंक ये मेरा लास्ट सेशन होगा आप लोगों के साथ में, आपके साथ काफ़ी अच्छा लगा। और एनीथिंग और कुछ जो फीडबैक हो तो देते रहिएगा। ओके गाइस।
सो भैया का आज लास्ट डे है, लाइक लास्ट डे नहीं, मतलब आगे भी
हाँ
जुड़ेंगे, बट आज के लिए तो
हाँ, लेकिन इस
इस
वर्कशॉप
वर्कशॉप
के लिए
में।
मेरा लास्ट है शायद।
सो अगर कुछ बोलना है तो स्पीकर माइक ऑन करके बोल दो।
हाँ, थैंक यू भैया,
अगर
बहुत मज़ा आया आपसे सीख के। आपने बहुत ज़्यादा वैल्यूएबल इंफॉर्मेशन दिया हमें, और पूरा क्लियर था, कुछ भी कंफ्यूजन भी नहीं हुआ।
ओके,
कल का सेशन के लिए
कल का
स्पीकर का
सेशन।
अनाउंस बता देंगे, कल इस बताया जाएगा।
ओके, सो ओके गाइस, तो अगर फिर ऐसी कोई फर्दर वर्कशॉप होती हैं तो फिर आपसे मिलेंगे।
क्या?
हेलो। हाँ, ओके, तो आप में से कितने लोग इलेक्ट्रॉनिक्स हैं बेसिकली?
भैया मैं भी
ओ
हूँ।
हो, अच्छा, आप तो वही। तो चलिए फिर नेक्स्ट लैब स्लॉट में मिलते हैं आपसे। आपकी बार में शायद अगर कोई ईएसटीसी का आपकी बार, अच्छा आपकी बार में था, लाइक इस बैच में फर्स्ट वाले स्लॉट में ईएसटीसी का कोई होगा? नहीं था इस वाले बैच में, मतलब अभी जो लैब्स हुई थी उसमें कोई गया था?
21 को।
ओके, चलो कोई ना,
अरे इतनी सारी लैब है,
नेक्स्ट
पहुंच जाएंगे।
पहुंच जाएंगे, मिलना बिल्कुल।
पैराडॉक्स।
बिल्कुल बिल्कुल, वी विल मीट एंड टेस्ट योर नॉलेज, कितना सीखा आप लोगों ने। ठीक है, और आगे अच्छे प्रोजेक्ट्स करते रहेंगे, आप जुड़े रहिएगा इस मतलब हम लोगों के साथ में। ओके,
सो
तो मुझे भी काफ़ी अच्छा लगा कि आप सभी के साथ मतलब अपना सेशन करने को, मेरा भी एक्सपीरियंस अच्छा ही रहा, और इतनी अच्छी ऑडियंस मिली तो फिर क्या ही कहना। और हमारे साथ जो हरिओम जी थे और काफ़ी लोग थे, तो उनको बहुत बहुत धन्यवाद कि उन्होंने मुझे इस जगह पे आने का मौका दिया। थैंक्स ऑल। ओके, सो हरिओम, ओवर टू यू। ओके,
okay. So if you guys don't have any doubt or suggestion or thank you sentence, so we can end this meet. Yeah, Pankaj.
Actually, it's Sukrut Bhujbal. I had doubt about that too. Is my attendance being marked as Pankaj or Sukrut?
We can mark like with your roll number. Okay, they are using your roll number.
Oh, okay. Okay. And thank you so much, Bhaiya, Utkarsh Bhaiya. It was a really great session. It was really informative. And I am a third year student of ETC branch, Electronics and
ओके,
Telecommunication.
ओके, ओके, सो लेट्स एंड
So
दिस सेशन। ओके,
yeah,
हाँ,
let's end.
ओके ओके, कंटिन्यू इफ यू वांट टू
No, no,
से
no.
समथिंग।
Yeah, yeah.
आई थिंक व्हेन द सर्टिफिकेट डिस्ट्रीब्यूशन।
Certificate distribution will be on 8, I guess.
ओके, आई विल बी देयर।
Yeah, yeah. Most welcome.
ओके, ओके, so guys, now the meeting is officially closed, so you can leave. Okay,
Yeah.
Thank you, Bhaiya.
okay.
Bye, guys. Thank you for your time.